Hello everyone. Our project GridGreen estimates your model's footprint from code and suggests lighter models and cleaner hours to run. Training or inferencing on a single large language model can emit more CO2 than a one-way flight from San Diego to Seattle. Running the exact same job 6 hours later on a cleaner electricity grid can cut that in half. But here's the thing, ML engineers never see any of this. Not before the hit run, not after, not on the bill. It's an invisible cost. We built GridGreen to make it visible in the editor before a single GPU hour is burned. GridGreen is a carbon-aware copilot that lives where ML engineers already work, their editor. You paste any training or inference script and it tells you three things. One, how much CO2 your workload will emit, grounded in public scaling laws. When I click run, two, a greener model you could swap to with the accuracy trade-off cited. Three, the cleanest hour in the next 48 hours to actually run it. All three in under 20 milliseconds. When I click Run Analysis, GridGreen passes the script with an AST walker. It finds two models, Plan, which is 11 billion parameters, and GPT, a closed API model. It estimates 14.24 kilograms of CO2 for this workload in the California region. But if I wait until 7 p.m. Pacific time, carbon intensity dropped 44%. Combining the swap and the timing, and we go from 62 kilos down to under 20. That's a 72% reduction from a 2-minute analysis. Now the swap. GridGreen does retrieval over a curated corpus of 58 model pairs. It suggests plan T5 large, 85% less compute, 94% of the MMLU score retained with the benchmark comparison cited right there. And this justification text, that's Gemini polishing the raw retrieval into something an engineer can actually read and trust. Here's what makes GridGreen more than a dashboard. I'm in Claude desktop now. I asked how should I run my Flan T5 XXL job now or should I wait? Checks our check grid rule, then finds cleaner window, then suggests greener options. It pieces together a grounded recommendation with our citations, our forecast, our methodology inside the conversation the engineer is already having. That's the copilot we wanted to build. For AIML track, we did a RAG which runs on our sentence transformers with Gemini polishing the reasoning layer. For cloud track, we ran our EIA pipeline, which is on a Databricks Delta Live table. Our vector index lives in Snowflake Cortex with vector float 384. Our embedding jobs run on NVIDIA Brev GPUs tracked in weights and biases. And we have an AWS SageMaker processing script for batch runs. We used US EIA hourly grid intensity across 5 balancing authorities.